Hello, and welcome to PH Maths. Number in focus on zero. Zero is the most powerful nothing in mathematics. It's the answer that makes a quadratic solvable, the why you set things equal to find roots, the place every coordinate grid starts. By the end of this video, you'll know why zero behaves the way it does, where it shows up in your exam paper, and the one thing you must never ever do with it. Quick identity check. Zero is even. Yes, really. The definition of even is divisible by 2, and 0 divided by 2 is 0, with no remainder, so it's in. 0 is neither prime nor composite. It sits in its own category. It's a whole number, and it's the additive identity. Add 0 to anything, and that anything stays the same. Multiples of 0. This is the shortest slide we'll do. 1 times 0 is 0. 2 times 0 is 0. 3, 4, 5, all 0. In fact, every multiple of 0 is 0, because multiplying anything by 0 gives you 0. That's a property called the absorbing element. 0 swallows whatever you multiply it by. Worth saying out loud, because the moment you spot a 0 in a product, the whole thing collapses to 0. Powers of 0. 0 to the 1 is 0. 0 squared, 0 cubed, to the 4th, to the 5th, they're all 0. Anything raised to a positive power, multiplied by itself any number of times, stays 0. 0 to the power 0, though, is a special case. By conventions, mathematicians take it as 1, because it makes other formulas work cleanly. You won't be tested on the y, but if your calculator shows 1, that is y. The three faces of 0. 1. Add 0 to anything and you get the same thing back. 0 is the additive identity. 2. Multiply anything by 0 and you get 0. 0 is the absorbing element. 3. And this is the rule that must never be broken. You cannot divide by 0. It's not 0, it's not infinity, it is undefined, and maths breaks at that point. Don't go there. Key relationships. A plus 0 is A. A times 0 is 0. 0 divided by any non-zero number is 0. Any non-zero number to the power 0 is 1. Yes, that includes some weird ones, but it's a rule. And 0 factorial, written 0 exclamation mark, also equals 1. It looks bonkers, but it's a convention that keeps combinatoric formulas from collapsing. Memorize these because they're rock solid. Where 0 actually appears in your GCSE Higher paper, the whole method for solving a quadratic is set this equal to 0 and factorize. To find a y-intercept, you substitute x equals 0. To find roots, you find where y equals 0. A discriminant of 0 means one repeated root, and the origin, the dead center of every coordinate grid, is 0, 0. 0 is everywhere on the paper. Where 0 hides, a minus itself is 0. Any difference of a thing with itself inside index identities. X to the 5th divided by x to the 5th equals x to the 0, which is 1, meaning the whole fraction reduces to 1. And on any graph, every constant term becomes 0 when x is 0. Spot a 0 hiding inside a problem and you've often spotted a shortcut. Hello, welcome to PH Maths. We're talking about the number 1. 1 is the quietest powerful number in the system. It looks like it does nothing, and that's exactly the point. By the end of this video, you'll know why 1 is the multiplicative identity, why it isn't prime, where it appears in trigonometry, and the sneaky trick of multiplying by 1 in disguise that rationalizes every third denominator on the syllabus. Quick identity check. 1 is odd. 1 is neither prime nor composite. It sits in its own special category. We don't call it prime because we want every number to have a unique prime factorization, and if 1 were prime, that would break. 1 is the multiplicative identity. Multiply anything by 1 and that anything stays the same, and both 0 factorial and 1 factorial equal 1. Multiples of 1: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Every integer is a multiple of 1. That's what multiplicative identity means in practice. The 1 times table is the simplest there is, but it's worth saying every fraction can be rewritten by multiplying top and bottom by 1 in some clever disguise. And that's the secret to half the algebra on the higher paper. Powers of 1. 1 to the 0, 1 to the 1, 1 squared, cubed to the 4th to the 5th, they all equal 1. 1 to any power, positive, negative, fractional, irrational, is 1. Always. That makes 1 a very useful sanity check. If you've simplified an expression and a power of 1 falls out, you know it's gone. And if you've rationalized correctly, a 1 in disguise has appeared and vanished cleanly. The quiet powerhouse of multiplication. 3 things make 1 special. 1. A times 1 is A for any number. 2. 1 to any power is 1 for any power. And 3. 1 is neither prime nor composite. It's in its own category. And that third point is the one that students get wrong. Do not say 1 is prime, because it's not. It's the multiplicative identity, and that is a category of one number only. Key relationships. A times 1 equals A. A divided by 1 equals A. 1 to the n equals 1 for any n. A to the 1 equals A. A divided by A equals 1 for any non-zero A. And 0 factorial equals 1 factorial equals 1. Notice how often the answer 1 falls out of an algebra problem. That's usually a sign you've simplified correctly and not made a mistake. Where 1 actually appears in your exam, the probability of a certain event equals 1, that's the upper bound. Sine squared theta plus cosine squared theta equals 1, the single most used trig identity on the syllabus. The coefficient of x when written alone is 1. The gradient of y equals x is 1. And ratios in simplest form often contain a 1. 3 to 1, 1 to 5. Where 1 hides, inside every fraction equal to 1. 4 over 4, x over x, a plus b over a plus b. Multiplying by 1 in disguise is the move that rationalizes surd denominators. And in probability, probability of failing plus probability of not failing equals 1. Whenever you see complementary events, that's 1 popping out. Lots of marks live in that pattern. Hello, welcome to PH Maths. Number in focus on 2. 2 is the only even prime, the base of binary, and the number that powers half the shortcuts in your exams. By the end of this video, you'll have the powers of 2 memorized. You'll know the surd it generates, and you'll be able to spot the doubling and halving pattern that quietly speeds up most mental arithmetic on the calculator paper. Quick identity check. 2 is even, and famously, it's the only even prime. Every other even number divides by 2, which means every other even number has more than 2 factors. So 2 is the smallest prime, and 2 is the base of binary. Every computer on the planet runs on powers of 2. Worth knowing for any indices question that looks weirdly clean. Multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Every multiple of 2 is even. That's the actual definition of even. If a number ends in 0, 2, 4, 6, 8, it's divisible by 2. The 2 times table is the fastest mental arithmetic trick you own. Doubling. Lean on it everywhere, from percentages to finding halves of awkward fractions. Powers of 2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared 4, cubed 8, to the 4th 16, 5th 32. They keep doubling. 64, 128, 256. Memorize these. They appear in standard form, in computing style questions, in indices, and in surd simplifications. If you see 4, 8, 16, 32, 64, that's a power of 2 saying hello. The triple agreement. 2 does something no other number does. 2 plus 2 equals 4. 2 times 2 equals 4. And 2 squared equals 4. Add, multiply, and square all give the same answer. Try 3. 3 plus 3 is 6, but 3 times 3 is 9. Try 4. 4 plus 4 is 8, but 4 squared is 16. Only 2 pulls off the triple. A small piece of trivia, but it tells you why 2 is special. Key relationships. 2 squared is 4, the smallest non-trivial square. 2 cubed is 8, the smallest non-trivial cube. Root 2 is about 1.414, a classic irrational surd, and the diagonal of a unit square. Sine 45 and cosine 45 both equal root 2 over 2. And the index rule, 2 squared times 2 cubed equals 2 to the fifth. Add the powers when multiplying. Where 2 actually appears in GCSE Higher, difference of 2 squares, a squared minus b squared factorizes to a minus b times a plus b. The quadratic formula has 2a in the denominator. Doubling and halving is the most reusable mental arithmetic trick you'll ever use. Surds like root 8 simplify to 2 root 2. And standard form numbers like 2 cubed times 10 to the fifth become 8 times 10 to the fifth. Where 2 hides, 4 is 2 squared, 8 is 2 cubed, 16, 32, 64, 128, 256, all powers of 2. Every even number by definition has a 2 in its prime factorization, and the diagonal of a unit square is root 2. Pop up a 1 by 1 square and a Pythagoras delivers root 2 every time. Spot the pattern, save time. Hello and welcome to PH Maths. The number in focus is 3. 3 is the smallest odd prime, the number of sides in a triangle, and the denominator behind one of the cleanest divisibility tests in the syllabus. By the end of this video, you'll have the powers of 3 memorized. You'll know root 3 as an exact trig value, and you'll be able to check divisibility by 3 at a glance. Quick identity check. 3 is odd. 3 is prime. 3 is a triangular number, i.e. a number that counts objects in an equilateral triangle. The sequence runs 1, 3, 6, 10, 15, and so on. And 3 is the smallest odd prime. 2 is smaller, but 2 is even. 3 is the first of the proper odd primes, the category that includes 7, includes 5, 7, 11, 13, and so on. Multiples of 3 and the times table. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. The 3 times table is one of the easier ones, but it's worth memorizing past 30 into 33, 36, 39, and so on. The divisibility test for 3 is beautifully clean. Add up the digits of any number, and if that sum divides by 3, the original number does too. Try it on 273. 2 plus 7 plus 3 is 12. Done. Powers of 3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared, 9. Cubed, 27. To the 4th, 81. 5th, 243. They grow fast. Memorize the first 4, 9, 27, 81, because they appear constantly in surd cancellation and indices. 81 in particular has the trick of being both 3 to the 4th and 9 squared, which gives you flexible cancellation options. The digit sum test. This is the rule that 3 is famous for. Take any number at all, and add up its digits. If that digit sum divides by 3, then so does the original number. Take 273. 2 plus 7 plus 3 is 12. 12 divides by 3, so 273 divides by 3. And indeed, 273 equals 3 times 91. That single trick saves you long division on factor questions. Key relationships and how 3 connects to the syllabus. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. Root 3 is about 1.732, a classic surd. Sine of 60, cosine of 30, and tangent of 60 are all built from root 3. These are exact trig values you must memorize. And the 3, 4, 5 right triangle, the smallest Pythagorean triple, has a 3 right at the front. Where 3 actually appears in your exam, exact trig values. Sine 60 equals cosine 30 equals root 3 over 2, and tangent 60 equals root 3. The divisibility test by digit sum. Cube roots. Cube root of 27 is 3. The smallest triangle has 3 sides, and the sum of interior angles of a triangle is 180 degrees, which is 3 times 60. Where 3 hides in other numbers, 9 is 3 squared, 27 is 3 cubed, 81, 243, 729, all powers of 3. 6, 12, 15, 21, 33, all multiples of 3. Easy to spot once you've done the digit sum test. If you ever face a fraction with a large numerator and you're unsure whether it cancels, run the digit sum test for 3, because it often saves vital minutes. Hello, welcome to PH Maths. Numbering focus on 4. 4 is the smallest composite number, a perfect square, and the first power of 2 that actually does anything useful. By the end of this video, you'll know why 4 marks the boundary between primes and composites, where 4 hides inside indices and Pythagorean triples, and the divisibility test that handles 4 with embarrassing ease. Quick identity check. 4 is even. 4 is composite, meaning it has factors other than itself and 1. Specifically, 4 equals 2 times 2. 4 is a perfect square, 2 squared to be exact, and 4 is a power of 2. The second one if you start at 2 to the 1. So 4 is composite, square, and a power of 2, all at once. It's a busy little number. Let's look at the times table and multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. The 4 times table is the doubling of the 2 times table. So if you've got your 2's cold, your 4's are halfway there. And the divisibility test for 4 is clean. Look only at the last 2 digits of any number. If those 2 digits form a number divisible by 4, the whole thing is. 324. 24 divides by 4, so 324 does 2. Powers of 4. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. Cubed is 64. To the 4th, 256. 5th, 1024. Here's the clean trick. Every power of 4 is also a power of 2. Specifically, 4 to the n equals 2 to the 2n. So 64 equals 4 cubed, which equals 2 to the 6. 3 identities pointing at the same number. Useful in indices questions. The smallest composite. Here's why 4 is genuinely special. 1 is in its own category, not prime, not composite. 2 is the smallest prime. 3 is also prime. So the first natural number that has non-trivial factors, that isn't just 1 times itself, is 4. 4 equals 2 times 2. It's the entry point into everything composite, every Venn diagram of prime factors, every factorization question on the paper. Key relationships and how 4 connects to the syllabus. 4 equals 2 squared, which equals root 16. 4 times 4 is 16, which is also 4 squared, which is 2 to the 4th. 4 cubed is 64, which is 8 squared, which is 2 to the 6th. Root 4 equals 2. Cube root of 64 equals 4. Half a circle in radians is 2 pi, and pi over 4 is 45 degrees. And quartiles split your data into 4 equal pieces, Q1, Q2, Q3. 4 is a divider, a square, and a power. Where 4 actually shows, the 3, 4, 5 right triangle, Pythagoras' first example, and the smallest whole number Pythagorean triple. Quadrilaterals have 4 sides, 4 angles, and an interior angle sum of 360 degrees. Quartiles in statistics split data into 4. Square numbers to recognize on sight: 4, 16, 64, 256. And the indices identify 4 to the n equals 2 to the 2n. Where 4 hides, 16 is 4 squared and also 2 to the 4th. 64 is 4 cubed and also 2 to the 6th and also 8 squared. That's the trickster number that's both a square and a cube. 256 is 4 to the 4th and 2 to the 8th. And the rule for divisibility: if the last 2 digits of a number divide by 4, the whole thing does. Save time on factor problems. Hello, welcome to PH Maths. Number in focus on 5. 5 is the hypotenuse of the smallest right triangle, half of 10, and the denominator behind almost every clean percentage. By the end of this video, you'll know why 5 sits inside the golden ratio, where it shows up in 2 famous Pythagorean triples, and the trick that turns awkward 5s into easy 10s. Quick identity check. 5 is odd, 5 is prime. 5 is a Fibonacci number. The sequence runs 1, 1, 2, 3, 5, 8, 13, and 5 lives inside the golden ratio. So phi equals 1 plus root 5 all over 2, which works out to around 1.618. 5 is one of those numbers that just keeps popping up in places it has no right to be. Let's look at the times table and multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The 5 times table is the easiest one in the syllabus. Every multiple ends in either a 0 or a 5. That's also the divisibility test. A number ends in 0 or 5, it divides by 5, period. Use this on every fraction simplification problem to spot whether you can knock out a 5 from the top and bottom. Powers of 5. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared, 25. Cubed, 125. To the 4th, 625. 5th, 3125. Memorize 25 and 125 because they appear in cube questions and percentage calculations. And here's a clean trick. 5 to the n times 2 to the n equals 10 to the n. Use it for fast mental arithmetic. Pythagoras' first triple. The 3, 4, 5 right triangle is the smallest whole number Pythagorean triple, and it sits at the heart of every non-calculator Pythagoras question in GCSE. 3 squared plus 4 squared equals 9 plus 16 equals 25, which is 5 squared. 5 is the hypotenuse. The other common one is 5, 12, 13, where 5 is now a leg. 5 wears both hats, a leg and a hypotenuse, depending on the triangle. Key relationships and how 5 connects to the syllabus. 5 squared is 25. 5 cubed is 125. 5 to the 4th is 625. Root 5 is about 2.236, irrational. The golden ratio phi equals 1 plus root 5 all over 2, which is 1.618 to 4 decimal places. 5, 12, 13 and 3, 4, 5 are the 2 Pythagorean triples involving 5. And 5 factorial, 5 times 4 times 3 times 2 times 1 equals 120. Where 5 actually shows up in your exam, Pythagorean triples, 3, 4, 5 and 5, 12, 13, the divisibility test, number ends in 0 or 5, square numbers to recognize, 25 and 625, cube numbers, 125 is 5 cubed, and percentages. 5% is a clean 1 over 20, which makes scaling up to 10% or 15% trivially fast in mental arithmetic. Where 5 hides, 25 is 5 squared, 125 is 5 cubed, 625 is 5 to the 4th, 3125 is 5 to the 5th, 10 is 2 times 5, 20 is 4 times 5, 15 is 3 times 5, 100 is 2 squared times 5 squared, and any number ending in 0 or 5 has a 5 tucked inside it. Cancel it down aggressively. Hello and welcome to PH Maths, number in focus on 6. 6 is the first perfect number, the product of the smallest two primes, and the answer to one of the cleanest divisibility tests on the syllabus. By the end of this, you'll know what makes 6 perfect, why hexagons are everywhere in nature, and the trick that tells you whether any number divides by 6 in about 3 seconds. Quick identity check. 6 is even. 6 is composite. 6 is a perfect number, and we'll come back to what that actually means. And 6 is a triangular number. The sequence runs 1, 3, 6, 10, 15, 21. 6 is the third triangular number, which is why 6 of anything stacks neatly into a triangle. Think bowling pins, billiard balls, classroom seating. Let's look at the times table and multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. The divisibility test for 6 combines two rules. A number divides by 6 if it's even, and its digit sum divides by 3. Both conditions, not either. So 126, even. The digit sum, 126, equals 9. 9 divides by 3, yes. 125 odd, no. 2 tests, 1 answer. Powers of 6. 6 to the 0 is 1. 6 to the 1 is 6. 6 squared, 36. Cubed, 216. To the 4th, 1296. And here's a lovely spotting trick. Every power of 6 ends in a 6. 6 squared ends in 6. 6 cubed ends in 6. 6 to the 4th ends in 6. So if a number is a power of 6, you will see the 6 on the end. Tidy. A perfect number. 6 earns the title perfect by two definitions, and they happen to give the same answer. Definition 1. The proper divisors of 6 are 1, 2, and 3. Add them together. 1 plus 2 plus 3 is 6. The divisors sum to the number itself. Definition 2. Multiply those same divisors. 1 times 2 times 3 is 6. So 6 is both the sum and product of its own factors. There are only 4 perfect numbers below 10,000, and 6 is the smallest. The others, by the way, are 28, 496, and 8,128. Key relationships and how 6 connects to the syllabus. 6 equals 2 times 3, the product of the smallest two primes. 6 equals 3 factorial, 3 times 2 times 1. 6 squared is 36. 6 cubed is 216. 6 to the 4th is 1296. A regular hexagon has 6 sides, each with an interior angle of 120 degrees, and the sum of those angles is 720. Where 6 shows up in your exam, highest common factor questions often boil down to 6. The highest common factor of 12 and 18 is 6. The highest common factor of 24 and 30 is 6. Hexagon area and perimeter problems lean on the angle of 120. Triangular numbers 1, 3, 6, 10, 15, 21 turn up in sequence questions. Divisibility, even and digit sum of 3, and factorials, 3 factorial equals 6, 4 factorial equals 24. Hello, welcome to PH Maths. Number in focus on 7. 7 is a strange one. It's prime. It's the number of days in a week. It's the number most people pick when asked for a random number, and weirdly, it's the only digit that turns any simple fraction into a recurring decimal. By the end of this, you'll have its times table cold, its powers locked in, and you'll know where 7 likes to hide in your exam paper. Quick identity check. 7 is odd. 7 is prime, meaning it only divides by itself and 1. 7 days in a week, which is why probability questions adore anything about days of the week. And the standout, 1/7 as a decimal, is 0.142857, repeating forever. We'll come back to that one because it's by far the most famous fact about 7. Times table. 1 7 is 7, 2 7s are 14, 3 21, 4 28, 5 35, 6 42, 7 49, 8 56, 9 63, and 10 70. The middle ones, 6 7s 42, 8 7s 56. That's where most students wobble. Memorize the 7 times table cold. It shows up in factor questions, in fraction simplification, and in hidden multiples like 77 and 91. Powers of 7. Anything to the power 0 is 1. That's a rule, not a fluke. 7 to the 1 is 7. 7 squared, 49. 7 cubed, 343. 7 to the 4th is 2,401. 7 to the 5th, 16,807. The one to lock in is 49. It shows up in Pythagoras questions, in surds, and in indices. Here's the magic of 7. 1/7 equals 0.142857, and those 6 digits then repeat forever. Now the wild part. 2/7 uses the exact same 6 digits, just rotated. 3/7, 4/7, all the way to 6/7. Same rotation of the same 6 digits. Try it on your calculator. The reason? 142857 times 7 equals 99999. And that's literally why 1/7 recurs at all. How 7 connects to the rest of the syllabus? Well, squared, it's 49. Cubed, 343. To the 4th, 2401. Root 7 is about 2.646, a classic irrational surd. So don't expect a clean answer when one appears. And the famous Pythagorean triple, 7, 24, 25, you'll see that on a non-calculator paper at some point, and recognizing it instantly saves you a full minute of squaring. Where 7 actually appears in your GCSE Higher exam, Pythagorean triple, 7, 24, 25, square number to recognize on sight, 49, recurring decimals, 1/7 has the longest cycle they'll throw at you, highest common factor and lowest common multiple problems often pair 7 with 14, 21, 28, and probability questions love days of the week, anything 1 in 7. Spot any of these and you've half solved the question already. Where 7 hides in other numbers, 49 is 7 squared, 343 is 7 cubed, 2401 is 7 to the 4th, 14, 21, 28, 35, 42, all multiples of 7. And if you ever see a decimal starting 0.142857 on your calculator, that's an n over 7 in disguise. Recognizing these can turn a long simplification into a single line of working. Hello, welcome to PH Maths. Numbering focused on 8. 8 is the smallest non-trivial cube, the third power of 2, and the number of vertices on a standard cube. By the end of this video, you'll have your cube numbers memorized, you'll know how to simplify root 8 in 2 seconds, and you'll spot the trickster number 64 that pulls double duty as both a square and a cube. Quick identity check. 8 is even. 8 is composite. 8 equals 2 times 2 times 2. 8 is a cube, specifically 2 cubed. And 8 is a power of 2, the third one, in fact. 8 is one of those numbers where every property points back to 2. If you know your 2's cold, you basically know your 8's. Multiples of 8. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Divisibility test for 8. Look at the last 3 digits of any number, and if those 3 digits form a number divisible by 8, the whole number is. So 1000 divides by 8 because the last 3 are 0, 0, 0, which is 0, which divides by 8. Useful for big number factor work. Powers of 8. 8 to the 0 is 1. 8 to the 1 is 8. 8 squared, 64. Cubed, 512. To the fourth, 4096. Every power of 8 is also a power of 2. Specifically, 8 to the n equals 2 to the 3n. So 8 cubed equals 2 to the 9 equals 512. 3 identities, 1 number. Helpful in indices questions. The smallest non-trivial cube. 8 equals 2 cubed, which makes it the smallest natural number, other than 1. That's a perfect cubed. But here's the magic. 8 squared is 64, and 64 is also 4 cubed, and 2 to the 6. So 64 is simultaneously a square, 8 squared, and a cube, 4 cubed. It's the smallest natural number to be both. Spot 64 in a question and you've got multiple cancellation routes. Key relationships. 8 equals 2 cubed. 8 squared is 64, also 4 cubed, also 2 to the 6th. 8 cubed is 512. Root 8 simplifies to 2 root 2. That's the third shortcut to learn. Cube root of 512 equals 8, and a standard cube has 8 vertices, the corners where 3 edges meet. Spatial geometry questions lean on that. Where 8 appears in GCSE, cube numbers 1, 8, 27, 64, 125, 216. Memorize that sequence cold. Cube root of 8 equals 2. Surds. Root 8 equals 2 root 2, a frequent simplification. Volume of a cube of side S is S cubed, so a 2 by 2 by 2 cube has a volume of 8, and the Pythagorean triple 8, 15, 17 does turn up occasionally. Where 8 hides, 64 is the trickster. It's 8 squared, 4 cubed, and 2 to the 6th all at once. 16, 24, 32, 40, 72, all multiples of 8. 512 is 8 cubed and 2 to the 9th. And any number ending in 3 zeros, 1000, 8000, is divisible by 8, because 1000 itself is. Spot the zeros, save the working. Hello, welcome to PH Maths. Number in focus on 9. 9 is a perfect square, 3 threes, and the absolute champion of divisibility tests. By the end of this video, you'll know the 9 trick, the one where multiplying 9 by any single digit gives an answer whose digits add to 9. And you'll be able to test divisibility by 9 on any number, regardless of size, in a couple of seconds. Quick identity check. 9 is odd. 9 is composite. 9 equals 3 times 3. 9 is a perfect square. 3 squared to be exact. And 9 is the digit sum champion. We'll come to that in a minute. 9 is the largest single digit, and it's also the last square number you'll see before you cross into 2-digit territory. Multiples of 9. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. Now here's the magic. Every one of those multiples has digits that sum to 9. 18, 1 plus 8 is 9. 27, 2 plus 7 is 9. 36, 3 plus 6 is 9, and so on. The divisibility test for 9, a number divides by 9 if and only its digit sum is a multiple of 9. Powers of 9. 9 to the 0 is 1. 9 to the 1 is 9. 9 squared, 81. Cubed, 729. To the 4th, 6561. And the indices trick, every power of 9 is also a power of 3. Specifically, 9 to the n equals 3 to the 2n. So 81 is 9 squared, 3 to the 4th, and root 6561 all at once. Lots of cancellation roots. The 9 trick. Take any multiple of 9 and add up its digits. The answer is always a multiple of 9. Try 45. 4 plus 5 is 9. Try 162. 1 plus 6 plus 2 is 9. Try 1008. 1 plus 0 plus 8 is 9. Even better, multiply 9 by any single digit. 9 times 7 is 63. 6 plus 3 is 9. Try it on any of them. It always works. Key relationships. 9 equals 3 squared, which equals root 81. 9 squared is 81. Also 3 to the 4th. 9 cubed is 729. Also 3 to the 6th. Root 9 equals 3 exactly. No surd needed. And the sum of digits of any multiple of 9 is a multiple of 9. That last one is the rule the divisibility test is built on. Where 9 appears in your exam, square numbers 1, 4, 9, 16, 25, 36, 49, 64, 81. Memorize the first 9 squares cold. Divisibility test by digit sum. Surds, root 9 equals 3. Never leave it as a surd. Indices, 9 to the n equals 3 to the 2n. And standard form, 9 times 10 to the n is often the upper bound of a number written in standard form. Where 9 hides, 81 is 9 squared and also 3 to the 4th. 729 is 9 cubed and 3 to the 6th. 18, 27, 36, 45, 72, 99, all multiples of 9. And any number with digit sum 9, 18, 27 or higher multiples of 9, that's a 9 in disguise. Spot the digit sum, save the long division. Hello, welcome to PH Maths. Number in focus on 10. 10 is the base of our entire number system, the reason place value works, and the workhorse behind standard form, percentages, and scientific notation. By the end of this video, you'll know what powers of 10 really do, why standard form is just 10 in disguise, and the simple reason humans landed on base 10 in the first place. Quick identity check. 10 is even. 10 is composite. 10 equals 2 times 5. 10 is the base of decimal, which means our entire number system runs on multiples and powers of 10. And 10 equals 2 times 5, the smallest two primes that multiply to a round number. The 2 times the 5 gives 10, an even, clean, easy to divide structure that 9, 11, and 12 simply don't have. Multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The divisibility test for 10 is the simplest one in the syllabus. Does the number end in 0? Yes, divisible. No, not divisible. That's it. Period. Multiples of 10 are the cleanest numbers to work with, which is why so much arithmetic is built around shifting decimal points up or down by a power of 10. Powers of 10. 10 to the 0 is 1. 10 to the 1 is 10. 10 squared, 100. Cubed, 1,000. To the 4th, 10,000. 5th, 100,000. 6th, 1 million. Each power of 10 just sticks another 0 on the end, and negative powers of 10 go the other way. 10 to the minus 1 is 0.1. 10 to the minus 2 is 0.01. That single rule powers standard form, sig figs, and decimal places. The base of everything. Why does our number system run on 10? Because humans have 10 fingers. That's the actual answer. Mathematicians could just as easily have built everything on base 12 or base 16, and computers run on base 2, but humans counted on their hands first, so 10 gets the prime spot. 10 to the n shifts the decimal point n places to the right. Negative powers shift it to the left. The whole machine runs on that single rule. Key relationships. 10 equals 2 times 5. 10 squared is 100. 10 cubed is 1,000. 10 to the 6th is 1,000,000. 10 to the 0, like any non-zero number to the 0, is 1. Log base 10 of 1,000 equals 3, because 10 to the 3 equals 1,000. And 10 factorial, 10 times 9 times 8 all the way down, equals 3,628,800. Where 10 appears in your exam, standard form, every number in standard form looks like a times 10 to the n, where a is between 1 and 10. Significant figures and decimal places all pivot on powers of 10. Multiplying or dividing by 10 shifts the decimal point. Probability questions sometimes use scales of 10. Out of 10, p equals x over 10. And every percentage is x over 100, which is x times 10 to the minus 2. Where 10 hides, 100 is 10 squared, 1000 is 10 cubed, 10,000 is 10 to the fourth, 50 is 5 times 10, 20 is 2 times 10, 90 is 9 times 10, 0.1 is 10 to the minus 1, 0.01 is 10 to the minus 2. Every percentage, every decimal shift, every standard form number has a power of 10 quietly doing the work. Hello, welcome to PH Maths. Number in focus on 11. 11 is a prime, a palindrome, and the only single-digit friendly prime whose early powers read the same backwards as forwards. By the end of this video, you'll know the alternating sum divisibility test, why 11 squared, cubed, and to the fourth are all palindromes, and the row of Pascal's triangle that ties it all together. Quick identity check. 11 is odd. 11 is prime. 11 is a palindrome. Read it backwards, still 11. And 11 squared, 121, is also a palindrome. 11 is the smallest two-digit prime, and the smallest two-digit palindrome that's also prime. It's a number with stupidly clean symmetry hiding behind it. Multiples of 11, 11, 22, 33, 44, 55, 66, 77, 88, 99, 110. Notice the pattern. Every two-digit multiple of 11 is just a repeating digit. The divisibility test for 11 is the alternating sum trick. Take a number, alternate adding and subtracting its digits from left to right, and if the answer is 0 or a multiple of 11, the original number is 2. Try 2915. 2 minus 9 plus 1 minus 5 equals minus 11. Divisible. Powers of 11. 11 to the 0 is 1. 11 to the 1 is 11. 11 squared, 121. Cubed, 1,331. To the fourth, 14,641. Read those backwards. 121 is a palindrome. 1331 is a palindrome. 14641 is a palindrome. The pattern only breaks down at 11 to the fifth, when carrying kicks in. Palindromic powers. Read them backwards, they're the same. 11 squared, 121. 11 cubed, 1331. 11 to the fourth, 14641. These are actually the rows of Pascal's triangle. 1, 1, 121, 1331, 14641. The binomial expansion of 1 plus 1 all to the n. Once you've squared to single digits past 9, carries break the pattern, but until then, 11's powers are pure Pascal in disguise. Key relationships. 11 squared is 121. 11 cubed is 1331. 11 to the fourth is 14641. 11 is the smallest two-digit prime. 11 is the smallest prime palindrome. And there's exactly one Pythagorean triple involving 11 below 100. But you won't see 11 in standard GCSE triples. It's more useful for divisibility and palindromic indices questions. Where 11 appears in your exam, divisibility test by alternating the digit sum, useful for any factor question with a big number. Square numbers to recognize, 121 is 11 squared. Surd questions, root 121 is 11, never leave it as a surd. Factorizing, 121x squared minus 49 factorizes as 11x minus 7 times 11x plus 7, and probability questions about two-digit primes. Where 11 hides, 121 is 11 squared, 1331 is 11 cubed, 14641 is 11 to the fourth, 22, 33, 55, 77, 99, these are all multiples of 11, and every palindrome with an even number of digits, like 1221 or 36563, divides by 11. Try it on a calculator. Always works. Hello, welcome to PH Maths. Number in focus on 12. 12 is the most divisible small number. The reason a dozen is a dozen, the reason a clock has 12 hours, and a frequent answer to highest common factor questions on the GCSE Higher paper. By the end of this video, you'll know why 12 is called highly composite, and you'll have 144 locked in, and you'll spot the 5, 12, 13 triangle on sight. Quick identity check. 12 is even. 12 is composite. 12 is highly composite, meaning it has more divisors than any smaller positive integer. And 12 equals 2 squared times 3, a clean prime factorization. Those factors are what make 12 so useful for splitting things evenly, into halves, thirds, quarters, sixths, twelfths. More options than 10 gives you. Multiples of 12. 12, 24, 36, 48, 60, 72, 84, 96, 118, 120. 12 has 6 divisors, 1, 2, 3, 4, 6, and 12, more than any smaller number. That's why ancient civilization measured in dozens, months, clock hours, and inches in a foot. 12 divides cleanly more ways than 10. Worth remembering when you're handed a sharing problem. Powers of 12. 12 to the 0 is 1. 12 to the 1 is 12. 12 squared, 144, the famous gross. 12 dozen. 12 cubed, 1728, also the number of cubic inches in a cubic foot. 12 to the 4th, 20,736. Memorize 144. It's one of the most used squares on the syllabus. Highly composite. 12 has 6 divisors. 1, 2, 3, 4, 6, and 12. That's more divisors than any smaller positive integer. 10 has only 4. 1, 2, 5, 10. 11 has just 2, itself and 1. So 12 absolutely smashes the divisor count for its size. That's why ancient measurement systems chose 12. The Egyptians, the Sumerians, and the Babylonians all used 12 for clocks, months, and geometry. 12 simply splits better than 10. Key relationships. 12 equals 2 squared times 3. 12 squared is 144, the gross. 12 cubed is 1728, a cubic foot in cubic inches. And here's a beautiful one. 12 equals 3 plus 4 plus 5, which is the perimeter of the 3, 4, 5 right triangle. Plus 12 inches in a foot, 12 months in a year, 12 hours on a clock face. Where 12 actually shows up in your exam, highest common factor questions frequently land on 12. Highest common factor of 24 and 36 is 12. Square numbers. 144 is 12 squared. Memorize it cold. The 5, 12, 13 right triangle is one of the most common Pythagorean triples on the paper. Probability questions use 12-hour clocks and 12-month years, and time conversions all lean on 12. Where 12 hides, 144 is 12 squared, also 16 times 9, also 4 squared times 3 squared, so lots of cancellation roots. 1728 is 12 cubed, 24, 36, 48, 60, 84, all multiples of 12. And 144 crops up everywhere. It's the dozen and one of the cleanest squares to factor. Hello, welcome to PH Maths. Number in focus on 13. 13 is the prime with the worst PR, unlucky 13. But in maths terms, it's the hypotenuse of one of the most common Pythagorean triples in the syllabus, the 6th prime and a Fibonacci number. By the end of this video, you'll spot 5, 12, 13 on instinct and know exactly where it shows up in your exam. Quick identity check. 13 is odd. 13 is prime. 13 is a Fibonacci number. 1, 1, 2, 3, 5, 8, 13, 21. There it is, the 7th term. And 13 is the hypotenuse of the 5, 12, 13 right triangle, the second most common Pythagorean triple after 3, 4, 5. 3 categories at once. a genuinely useful number. Multiples of 13, 13, 26, 39, 52, 65, 78, 91, 104, 117, 130. 13 doesn't have a clean divisibility rule. It's one of those primes you basically have to memorize the multiples for. The two to remember are 52, which is the number of cards in a standard deck, and 91, which is 7 times 13, a common factorization trap. Powers of 13. 13 to the 0 is 1. 13 to the 1 is 13. 13 squared, 169. Cubed, 2,197. To the 4th, 28,561. Memorize 169. It appears in Pythagoras questions absolutely constantly because 5 squared plus 12 squared equals 25 plus 144 equals 169. Pythagoras' second triple. 5 squared plus 12 squared equals 25 plus 144 equals 169, which is 13 squared. So the 5, 12, 13 right triangle is the second whole number Pythagorean triple after 3, 4, 5. It shows up on non-calculator higher papers every year. Recognizing it instantly, instead of squaring and adding, saves you a full minute of working. 13 is also the 7th Fibonacci number, where the Fibonacci sequence first crosses into double digits. Key relationships. 13 squared is 169. 13 cubed is 2197. 5 squared plus 12 squared equals 13 squared, your second Pythagorean triple. 13 is the 6th prime if you start counting from 2. Root 13 is about 3.606, irrational. And there are 13 cards in each suit of a standard 52 card deck, which is why card-based probability questions often use 13. Where 13 appears in your exam, the 5, 12, 13 Pythagorean triple. Spot it, save a minute. Square numbers, 169 is 13 squared, memorize it. Probability questions with cards, 52 cards split into 4 suits, each with 13. Higher tier surd questions sometimes hide a 13 in the answer. And in real-world context, year 13 is 6th form, the year you'd be sitting A-levels. Where 13 hides, 169 is 13 squared. 2197 is 13 cubed. 26, 39, 52, 65, 91, all multiples of 13. And 91 is the sneaky one. It looks prime, but 91 equals 7 times 13. Spot that and you'll save yourself trial dividing every prime up to 10. Always check 7 and 13 on awkward 2-digit factorizations. Hello, welcome to PH Maths. Number in focus on 14. 14 is 2 times 7, the number of nights in a fortnight, and an easily overlooked multiple of 7 that turns up in highest common factor and lowest common multiple problems all the time. By the end of this video, you'll know its divisibility test, its useful mental anchor at 196, and exactly when 14 is hiding behind a problem that looks like it's about 7. Quick identity check. 14 is even. 14 is composite. Specifically, 14 equals 2 times 7. So 14 is the smallest even multiple of 7. And 14 is a fortnight. 14 nights, 14 days. The word fortnight actually comes from the Old English for 14 nights. Comes up in time and money problems in the calculator paper. Multiples of 14. 14, 28, 42, 56, 70, 84, 98, 112, 126, 140. The divisibility test for 14 combines 2 simpler tests. A number is divisible by 14 if it's both even and divisible by 7. Both conditions, not either. So 112 is even, 112 divides by 7, therefore 112 is divisible by 14. Quick double check, big payoff. Powers of 14. 14 to the 0 is 1. 14 to the 1 is 14. 14 squared, 196. Cubed, 2,744. And here's the useful mental anchor. 196 is just below 200. Whenever you need a quick estimate of 14 squared, round it to 200 and adjust indices. 14 to the n equals 2 to the n times 7 to the n. A fortnight. 14 equals 2 times 7, which is why 14 is one of the cleanest 2' products you can build. The smallest prime times the fourth prime. And fortnight, from the Old English Fuertetain night, meaning 14 nights, is the British word for 2 weeks. Pay fortnight, fortnightly bills, fortnightly publications, comes up in financial maths and in data questions where time periods are spaced 2 weeks apart. Key relationships. 14 equals 2 times 7. 14 squared is 196, just below 200. Useful for estimation. 14 cubed is 2744. Root 14 is about 3.742, irrational. And a fortnight is 14 nights. The prime factorization is tiny, 2 times 7, so 14 plays nicely in any highest common factor or lowest common multiple problem that involves 7, 14, 28 or 42. Where 14 actually appears in your exam, highest common factor and lowest common multiple questions often pair 14, 21, 28 and 42, which are all multiples of 7. Square numbers. 196 is 14 squared, useful as an estimation anchor for 200. Indices. 14 to the n equals 2 to the n times 7 to the n. Probability questions that use a fortnight as the time period. And age questions. 14 is often the start of the GCSE year. Where 14 hides, 196 is 14 squared, 2744 is 14 cubed, 28, 42, 56, 70, 98, all multiples of 14. And any even multiple of 7 is automatically a multiple of 14. So if you see 28 in a factor question, that's 2 times 14 or 4 times 7, depending on how you want to break it down. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE Higher Revision Planner ready to download. Plus, hello, welcome to PH Maths. Number in focus on 15. 15 is 3 times 5, the fifth triangular number and the the leg of the lesser known 8, 15, 17 Pythagorean triple. By the end of this video, you'll see why 15 is one of the most mathematically rich small numbers and exactly where it hides across the GCSE Higher paper. Quick identity check. 15 is odd. 15 is composite. 15 is a triangular number. 1 plus 2 plus 3 plus 4 plus 5 equals 15, the sum of the first 5 natural numbers. And 15 equals 3 times 5, the product of the 2 smallest odd primes. 3 different categories, all converging on the same little number, worth paying attention to. Multiples of 15. 15, 30, 45, 60, 75, 90, 105, 120, 135, 150. The divisibility test for 15 combines 2 simpler tests. A number divides by 15 if it's divisible by both 3 and 5. 5 means it ends in a 0 or 5. 3 means the digit sum divides by 3. Both tests at once, fast result. Try 75. Ends in 5. Digit sum 12. 12 divides by 3. Done. Powers of 15. 15 to the 0 is 1. 15 to the 1 is 15. 15 squared, 225. Cubed, 3,375. And here's the cancellation gold. 225 equals 9 times 25, which is 3 squared times 5 squared. So 15 squared has a beautifully clean prime factorization, worth memorizing for any surd or factor question. The fifth triangular number. Triangular numbers come from stacking dots in triangles. 1, then 1 plus 2, then 1 plus 2 plus 3, and so on. So 1, 3, 6, 10, 15. The fifth triangular number is 15. and you can see it geometrically as a triangle of 5 rows. The formula for the nth triangular number is n times n plus 1 all over 2. So the fifth is 5 times 6 over 2, which is 15. Showed up in any sequence question? Triangular. Key relationships. 15 equals 3 times 5. 15 equals 1 plus 2 plus 3 plus 4 plus 5, the fifth triangular number. 15 squared is 225, which factors beautifully into 9 times 25. That is 3 squared times 5 squared. 15 cubed is 3375. And the 8, 15, 17 Pythagorean triple has 15 as a leg, not a hypotenuse, noted occasionally on higher papers. Where 15 actually shows up in your exam, the 8, 15, 17 Pythagorean triple, square numbers, 225 is 15 squared and it cancels beautifully into surds. Triangular numbers, 1, 3, 6, 10, 15, 21, the fifth term is 15. Probability questions with sets of 15 outcomes, and percentages. 15% equals 0.15 equals 3 over 20, a useful mental shortcut. Where 15 hides, 225 is 15 squared, which is also 9 times 25. 3375 is 15 cubed. 30, 45, 60, 75, 90, all multiples of 15. And any odd multiple of both, 3 and 5, 15, 45, 75, 105, is automatically a multiple of 15. Use the digit sum test plus the ends in 5 test and you'll spot 15 in seconds. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE Higher